Hi, Amanda.
Hi. Is anyone else coming tonight?
Do you know Andrew?
David just said yesterday, he said he'd try to be here, is all he said.
Okay. Was that other guy, was his name Felix?
No, Dirk.
Oh.
Yeah.
I thought I saw someone, someone named Felix commented on a video or something. I don't know.
Huh.
I don't know.
Yeah, I haven't gotten any emails from anyone else, so I'd assume that no one's coming if David doesn't show up here in a little bit.
Yeah.
Okay. Were you able to get the preparation assignment done?
Yes.
Okay. Did you understand it okay?
Yes.
Okay.
Let me see. Yeah, I used the, I didn't use SPSS, I used Excel for the quantitative descriptive statistics part.
I did too, and it was actually a lot easier.
Yeah, that SPSS is too confusing for me.
Yeah. Well, and it made my computer really slow, so I'm like, we'll just use Excel. It was easier.
Did you submit your group meeting from yesterday?
Yeah, I did. I got 8 questions wrong.
Yeah.
Is that how many I got? I think so.
We got an 81%. I don't know. We didn't.
Oh,
So,
I think because, I think
3, 4.
I got 78%, but I think that's because I answered number 8 differently. I put systematic, but then you guys probably put stratified.
Oh, okay. Number 8?
Yeah.
Okay.
Yeah, we put stratified.
So I think that's...
Yeah, so we got 7.
You guys got 7 wrong, and then I got 8 wrong.
Yeah.
8 questions wrong.
I can't figure out why we got the number 23 wrong. It was the between what two measured between the 68 or between the mean or whatever we decided.
Oh yeah.
Approximately 68%.
Well, we got number 22 wrong, right?
Yeah, so I think that's had to do with it.
So that would be why, because we used number 21 and 22 to get 23.
Okay.
So if we had 21 or 22 wrong, then 23 was automatically wrong.
Right. Okay.
Yeah, that makes sense.
Okay.
But I don't know what we did wrong for 24 or 25.
Yeah, I couldn't. Yeah, I thought maybe we rounded wrong.
But I thought that too. But I mean, I redid them and it was the same.
Oh, really? So maybe we just did the wrong calculation?
Yeah. But I don't know what else it would be given that story.
Well, I don't think that David's coming.
Yeah, I don't think so either.
We could probably just get started. Do you want to open up the preparation assignment? We'll go through that. We just have to do part 2, right?
Yes.
Okay, let me turn to the right. Okay, so for part 2...
So I think there's just 2 problems, but then they have the A, B, C, D.
Yes. Okay, so Andrew's pulling that up really quick. I just have the answers. I don't remember what the questions are. I'll start, I guess, for A, I got null equals 529 because that was the assumed truth. And then for the alternative, they were thinking that the mu was going to be greater than 529.
Yep. I got the same thing.
Okay.
For B, I got type 1 error was committed because the truth was rejected.
Yeah, perfect.
And then for C was just 1%.
That's what I got.
And then you would need to increase. Right?
Right. Yeah, increase the level of significance. Because in the video he said when one thing goes up, the other one goes down. So
Right.
the probability was decreased, so then you increase the level of significance.
Okay, perfect. And then for 2, I said the population equals the second time home buyers. And then how did he collect his data was randomly selected. And then the question that we were looking for would be the average age of the average age of the people buying a home for the second time in his area, and if it was different than the average age of people buying a home for the second time, like, nationally.
Right, that's what I got too.
Okay. And then what was that?
B, I think it could be like multiple things, but I put you could list all of the clients in an Excel sheet and then number the clients, or you could use a random number generator with a computer.
Yeah, we put
Drawn from a hat.
Yeah, how about put all his clients in a hat and kind of draw from it. So yeah, similar.
Yeah, that makes sense.
For the mean, I got 46.733.
Okay, that's what I got. Standard deviation, I got 8.827.
Okay.
The variance 77.923.
And then
would that round to 924? Because I think it was 77.9238.
8, yeah.
Okay.
And then the minimum 27?
Yep. And quartile 1, 41.5.
Perfect. That's all we just had to do the first 5, right?
I don't know. I did all of them, but
I didn't know because it just kind of was random. Like, what does C say? I think it said just the first 5, but then I kind of felt like it just kind of cut off some of the information. So it's 2C. So it's gonna be fun.
describe.
Right here. Let's go down a little more. Right.
Oh, it said, yeah, use at least 5 descriptive statistics. So,
okay.
Yeah, that makes sense.
Okay, so I only stopped there, but I kind of thought it was weird. But okay, so for I got when I did the QQ plot, I found that it was normal. And then for D number 2, the null equals 47.
And then alternative, it said I put, so if the null was mu equals 47, then for the alternative I put mu does not equal 47.
Yeah, I just said alternative is different, so yeah, it's not 47, yeah. It's a two-tailed because we want to know both sides. Is that right? I didn't...
Wait, for the third one?
Yeah. Was it two-tailed?
Wait,
It's still D, like number 2.
Okay.
I think it asks.
Is this a 1 or 2-tailed test?
Number 3.
One tailed. No.
2.
Yeah, because if the alternative doesn't equal, then it has to be two-sided, right? Two-tailed. I think that's what I read in the reading.
Oh, right. So, okay, two-tailed.
And then number 3, it just gives us a thing. It doesn't really have us do anything. And then what did you get for 4?
4, I put z-score equals 0.209.
And you got a negative, right?
Yeah, negative.
Yeah, perfect. And then I got a p-value for number 5 as 0.8344.
Yep, that's what I got.
And then number
And then 6, I got the p-value is greater than the level of significance. So then 0.8344 is greater than 0.05. So
Right.
p-value is greater than level of significance. And then, which means we fail to reject the null.
Perfect.
Is this national?
Yeah, national. Huh? Actually. And then, so what we kind of discovered was we don't have enough evidence to support that the mean age is different in one area than it is nationally. Therefore,
Right.
the alternative is not true.
Right.
And then I didn't find any other actions I would have him do. Did you think of any?
I put just not really anything specific, but just for the realtor to like keep targeting that same population of middle-aged people.
Okay, yeah.
Buyers, like, but not really anything changing.
Yeah. Yeah. Yeah, I think that's right. Okay, perfect. We'll go on to the group meeting. Do you want to open yours up too?
Okay.
Okay, so you want to read number 3, Andrew?
Okay. So number 3, are you guys there already?
Andrew's almost there, yeah.
Yeah, go ahead.
Okay, so number 3, a hypothesis test consists of 2 hypotheses, the null hypothesis and the alternative hypothesis. Which one represents the status quo?
The null.
Yeah, the null, right?
Yeah, the null, because that determines whether you reject it or not, right?
Right, yeah. And I think the status quo is, yeah.
Always assume that it's...
Yeah.
Right.
And then it says, which hypothesis involves equality in, isn't that the null too? Because isn't the alternative considered different? And
what does it mean involves equality? Because...
Well, okay, so when I was watching the video, he was showing how null can equal 0, but the alternative can either be greater than, less than, or not equal to.
Oh, that's true. Yeah, so it would be the null. That makes sense.
Okay, Andrew, I'm going to write this one.
The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer questions 5.
Question
5. Okay. When computing this probability, which hypothesis do you assume to be true?
So p-value is... So the p-value is
the probability
equal to what was observed. Is that what it's saying? At least as extreme?
Yeah.
So it's like equal to or greater than?
I don't know when it says at least.
Yeah.
Is this like one?
Because at least that doesn't mean, that means it could be equal to or greater than, but not less than.
Yeah. I just have that down as a definition, but I didn't Okay, so it says The probability of obtaining a test statistic at least as extreme as the one that was actually observed, assuming the null is true. So is it the null again?
Wait, read that again?
Says the probability of obtaining a test statistic at least as extreme as the one that was actually observed, assuming the null is true.
Yeah, I'd say null.
Okay.
Again.
null
Because,
so
yeah, that would make sense because if it's at least, that could be equal to or greater than, but the alternative can't be equal to.
That's true.
You assume to the null hypothesis to be true.
Yeah. Okay. So, go to the next one.
Suppose the null hypothesis is 10. Use this information to answer question 6 through 8. Which of the following represents the alternative hypothesis for a two-tailed test?
So it would be
mu not equal to 10, right?
wait, is this representing the alternative? So then wouldn't it be mu is less than 10?
Well, less than and greater than are just one-sided, making them either a left tail or a right tail.
Oh,
The only one that's two-sided is not equal to, and then that causes it to be two-tailed.
okay. Two-tailed is not equal to.
And that I found in the book when I was reading about it.
So this is left tail?
Yeah, yeah.
Or left tail, right tail?
And then two-tail.
Not tail.
Yeah. Wait, no. This one is two-tail. This one doesn't have a tail. Is it equal? Okay, so which of the following represents the alternative hypothesis for a left-tailed one? So then a left tail would be less than.
Okay, that makes sense. So then the right-tailed would be greater than.
Yes.
And then a two-tailed is this?
Yeah, two-tailed
So
is not equal. That doesn't have a tail, it's the null.
Oh.
That can only be the null.
Oh.
Okay, then 9. The outcome of a hypothesis test is determined by comparing the p-value to the level of significance, or A. Use this information for questions 9 through 10. Which relationship would result in failing to reject the null hypothesis? So, failing to reject the null hypothesis.
Wouldn't it be p-value is greater than A? Because, where was it? Where did I write that down? Okay, if the p-value is lower than alpha, then we reject the null. If p-value is higher than alpha, then we fail to reject the null.
So in this one, we failed to reject the null, so p-value is greater than alpha.
Yes. Did I say less than? I can't remember. Yeah, but it's greater than.
Okay.
So in which relationship would result in rejecting the null would then be less than?
Right. So p-value is less than alpha.
Okay, they're doing this one right here.
What, 11?
Yeah.
An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for questions 11 through 12. Which of the following would be appropriate alternative? Which of the following would be the appropriate alternative hypothesis?
And
alternative hypothesis.
And the alternative usually is going to be the last sentence, right?
greater than...
And that the true mean is actually higher than this?
Yeah. So then the average claim amount is greater than 1,500.
Right.
Because then the null would be...
Less than.
No, the null would actually be that they that the claim amount equals 1,500 because that's what the average is. So usually the average they think is what it is.
Yeah, null hypothesis would be.
Right.
So which of the following would be appropriate alternative hypothesis?
Yes,
would be?
they are concerned that the true meaning is actually higher. That's the alternative.
Wait, isn't... So the null hypothesis is what was previously assumed to be true, and it didn't change, so that's what they thought it was, and it was true? But then the alternative is what they want it to be, right?
Yes, and it could go either way when you figure it out.
Okay, so 11 would be greater than, and then 12 would be equal to.
Yeah, which of the following would be appropriate? Yeah, would be equal. Did you get that, Andrew, for number 12? Equal. Okay, the insurance company randomly selected n equals 40 claims and calculates a sample mean of 1,650. Use these to answer 13 through 15. Scroll down, please, so I can read this.
Okay, the insurance company assumes the distribution of sample mean is normal. Is this a good assumption?
So the sample size, would that be considered a big sample size?
I don't know. Did they specifically tell you, like, if it's over this?
Or do we just use it what they're saying for that?
Because we have to use those two, like the law of large numbers or the central limit theorem.
Yes, but I think this is what, okay, so when we had to do that QQ plot, it said that if the sample size isn't greater than 30, and we don't know if it's normally distributed, then we have to do the QQ plot. So I'm guessing greater than, if it is greater, if it is, I think that it has to be greater than 30 in order to be considered a large sample.
Okay, and it's 40, so...
Yes, I would think yes.
Yeah, so I'd say yes, it is normal, because when the sample size is large.
Yeah. I could be wrong, but that's what I...
What theorem or law describes your answer to the previous question?
Which one? Which one says the...
Law of large numbers means the standard deviation gets small.
I think
so it'd be this and...
The central limit theorem is the...
central limit theorem.
The law of total probability.
So I think, yeah. There's one that has to deal with the sample size. Is that the shape one?
Yeah, that's the central limit theorem because the law of large numbers you would need to know more information because it just gives you the sample size and the mean. But the law of large numbers, the mean is close to, like the sample mean is close to the population mean, but we only know the sample mean.
Okay, so yeah, we'll go central. Okay, which of the following is the... Sandra, please stop. Which of the following is the test statistic as defined in the lesson? I don't know that one.
Yeah, I don't.
Which of the following is the statistic as defined in the lesson? Oh, well, I got it.
Here we go. It's in 4.2. In...
You just said in 4.2.
Huh?
You said it's in 4.2, so scroll up here in 5 right now.
So in the book, 4.2 is titled Test Statistics. So
Observation 3. What is it? It's asking what the test statistic is.
Yeah.
Test statistic.
Well, it either have to be S or N, but N is sample size. X bar is sample mean.
wouldn't it Wait, is
Z-score.
Z an option?
Well, Z is Z-score.
But
So,
test
the only one we don't have, like, at 4 is S, but I've never heard of an S either.
test statistic.
Okay, so test statistic is when you take what is the hypothesis test? It just says called its test statistic. The p-value is the
I
probability.
think it might be Z because when I type in test statistic definition, it says a Z-test is any statistical test for which the distribution of the test statistic under the null hypothesis can be approximated.
Alrighty. Well, that's more than we found, so perfect. We'll go with that one. Okay, so...
Okay. I'll read 16.
Okay.
The historical mean of sales receipts at a grocery store is 150, with standard deviation of 40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypothesis. She will use a level of significance of A equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X equals 144. Use this information for questions 16 through 18. 16. What is the z-score associated with this test? So we have to use that equation.
So 150 minus 144.
Well, wouldn't it be
144 minus
150?
150.
That's what I meant.
Did it give us a sample size? Yeah, 36.
Yeah.
What's the square root of that is 6, right? Can you hand me that? So do this first. Oh, -6.
No, just 6. Oh. Yeah. 40.
Another square root of
6.666.
So 6, 7. So -6.
I got negative 0.900 rounded.
Okay, hold on. Sorry. Okay, so you got negative
.899.
899.
But then wouldn't it round to negative 0.900 because they're all
Decimal places.
Yeah.
numbers?
Yeah. So the z would score be negative 0.900. Okay. What is the p-value associated with that? And then we would put that into the probability, right?
Yeah. So normal probability output. And then we would shade in both the left and the right and then use the area, right?
Yes. Just Google probability.
Yeah.
Or I guess I just pulled Google. Right there. Mm. So then you put this in the z-score.
-9.
Yep. Negative point. Mm-hmm. Nope, just keep it and then just push enter. Okay, so did you find it yet?
Yeah, I got 0.368.
That's what we got to do, right, Andrew? Yep.
Okay.
Yep, 0.368, which then means that's less than the...
Wait, that would be greater than the level of significance.
Oh, you're right. Yes, that is greater.
So
So
then that would mean we failed to reject the null.
yes. Okay, and then which one would be type 2, right?
Failing. So that's rejecting the null hypothesis when the null is true.
Is that what type 2 is? It is rejecting.
So that's rejecting the null hypothesis when the null is true.
Or is that type 1?
Wouldn't that be type 1?
Yeah.
Rejecting what was true?
Yeah, it's true. Yeah.
Okay. Okay. 20. A researcher decided that instead of using a level of significance of A equals 0.05, he will use A equals 0.01. Which of the following will be true? Let's see. So it's 0.01. Wouldn't it just stay the same because the p-value would still be greater than, because the level of significance is increased.
Yeah, so the probability of type 1 error will increase. Right?
Yes. Right. Because level of significance decreases, then the probability increases. Okay.
And I have no idea what 20's asking, or 21's asking.
Compute the probability of committing a type 1 error. I think that's where we get percentage. So
5%.
yeah, wouldn't it just be, do they want it in percentage form then?
Well, it won't let me type 5%.
Yeah, it's not letting me do a percentage.
So then I guess just
0.050.
Yeah, I think.
Because, like, when in the homework,
Yeah.
I think it was question 1C,
Yeah.
said 0.01 level, and then the answer was 1%, 0.01.
Yeah.
So.
Does it let you type? Like, could you do 5? Nope, it doesn't. So just, yeah.
It doesn't let me do a percentage sign, so. I mean, then we just put 0.050.
Perfect.
Okay. Let's see.
Is that good?
Yeah, I think that's it, don't you think?
Yeah.
That was the fastest one, wasn't it? Okay.
Well,
maybe one of our fastest ones.
One of them. Let's hope now we did good. You.
Should we try to see more about that one question about the test statistic?
Which one was?
I'm pretty sure it's Z, but I'm not.
Oh, yeah. Did you see it all in the book? Were you looking in the book?
No, I just typed it in Google and it was saying Z, but then
Was it in this last one?
because I typed in test statistic definition.
Because we're in a new chapter. Because this isn't going to be on our test.
Yeah.
Oh, test statistics right there.
Z. This is called the test statistic. Z equals X bar over minus
Okay.
U over standard.
What does it
It
equal
talks
there?
about the Z test, so I'm pretty sure it is Z.
Okay. Perfect. Well. Okay, I think we did good on all the other ones.
Yeah, me too.
Okay. Well, I'm gonna submit it. I'll let you know.
Okay.
Oh, we missed one. Which one did we miss?
Missed more than one.
I
Wait, why did I do that?
I don't know. We missed 20.
20.
Yeah, the probability of a type 2 error will increase.
Wait,
Oh.
that doesn't. But
And,
the level
and we got the p-value wrong
for which one?
for 17.
Oh, wait. But we got the Z-score right?
Yep.
How is that possible? 3, 6, 8. They want us to round to 3 decimals. We did that. Because the p-value is just putting in the Z-score and then shading in left and right.
Yeah.
I don't know why.
Did you do it again? Did you put in negative?
Yeah, in the normal probability applet, and it's still 0.3681.
Yeah, I don't know.
So, are we supposed to shade in something different?
I didn't think so. Not on the homework we didn't.
I know, on the homework it was shading in the left and the right.
Yeah.
So,
Yeah, I don't know. You just
but then with 20, if the level of significance decreased, wouldn't the probability increase?
Yeah, it does increase, but on type 2, not type 1.
But why type 2 if 19 was type? Oh,
I don't know. When he was talking about it, it was like I understood that like if one increased, the other decreased, but I didn't understand how it did it with type 1 and type 2 and how you would just decide.
Yeah. Yeah, I don't know how to do that. 17. I don't know how else to do that one, but everything else is good.
Yeah, we'll have to.
What number?
I don't know. It was number 19.
No, not that one.
It's right here. I did just check. Yeah, sorry, I don't know how to help with 17. I thought we did it right.
It's okay. I submitted it.
So, okay, perfect. And then back to Tuesday then at
Yes.
what time? 9 your time.
Right. Okay, so next week we'll do Tuesday and Thursday. I can be group lead next week.
Okay, perfect. Yeah, that sounds good.
Okay.
Alrighty, and good luck on the test. Have you taken it yet?
No, I haven't. I'm not sure how it's gonna be.
I know, we're a little nervous too.
Hopefully it's similar to our group work from yesterday.
Yes. Yes, yes. That's what we're hoping. But
I don't know. Sometimes the homework is really different than the group meeting.
yes. Last week we did fairly well on I think our group meeting. I think we got an A, and then on our homework, yeah, we got an A on our group, and I got a C minus, and I think Andrew got a D on the homework.
Yeah.
We're like, this was nothing like what we did.
Yeah, I got a D on the homework too, and I was like, I did everything the same as the group work, so I don't know.
Oh, yeah, we were super annoyed.
Yeah.
So yes, hopefully the test isn't too hard.
Yeah.
But alrighty, have fun at your friend's wedding.
Thanks, I will. Have a good Memorial weekend.
All right,
Thanks.
you too.
See ya.
Take care.
Bye.